Okay, so you guys have just finished 5.4, where we introduced you guys to four-sided polygons, right? So we've had some four-sided polygons. We're going to go more into the properties that these four-sided polygons have, and we are going to start out with the father of our quadrilateral. So quadrilateral is like the grandparent. Parallelogram is like, the father. And so I recommend you guys looking in your books at page 241 and 242 if you would like to copy down all of the exact properties that we are going through. I'm going to show you them in a more visual approach. So the first property of a parallelogram is the definition of parallelogram. So if a quadrilateral is a parallelogram, then opposite sides are parallel. Okay? So if quadrilateral is parallelogram, opposite sides are parallel. The next property, if a quadrilateral is a parallelogram, then opposite sides are congruent to each other. So it's also true that the opposite sides are congruent. My next property is if a quadrilateral is a parallelogram, then opposite angles are congruent. So all of angle A is congruent to all of angle L. Those are equal to each other. All of angle P is equal to all of angle R. They have the same value. They're equal to each other. Next, the diagonals will bisect each other. In a parallelogram, the diagonals bisect each other. So this diagonal got bisected as well as this diagonal that got bisected. Okay, so the diagonals bisect each other, and the consecutive angles are supplementary. So for example, if I was to tell you that angle A is 80 degrees, you will be able to identify how big all of the other angles are. So obviously if angle A is 80, we've already went over that opposite angles are congruent to each other, so this angle would be 80. But also consecutive angles, so angles that are next to each other, are supplementary. So those angles have to add to 180, those angles have to add to 180, so on and so forth. So if this angle right here, angle A is 80, then angle R coming back over here has to be 100 degrees in order for it to be supplementary. If R is 100 degrees, then P also has to be 100 degrees. Okay, so opposite angles congruent, consecutive angles are supplementary. Next, we're going to focus on the rectangle. So the properties of a rectangle are all the properties of the parallelogram, and that's why we started with the father figure of parallelogram. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other. Okay, so all of those things hold true, plus more. Specifically, all the angles are right angles, and you guys know this, but all the angles are right angles. So if you are given a rectangle, you know that all of those angles are right angles. And also the diagonals are congruent to each other. Okay, so what that means is that this diagonal of RC is congruent to this diagonal ET. The diagonals are congruent. If you go back up here and look at the parallelogram, you can very clearly see that this blue diagonal is a lot longer than the pink diagonal. And that's because our shape is kind of smushed to the side. But we know that in a rectangle, all of the things from above hold true, plus there are right angles and the diagonals are congruent. Next, we have our kite. And for the kite, I want you guys to think about the equidistant theorem that we just talked about, right? So the reason that this is a kite is because there are two disjoint pairs of consecutive sides that are congruent. What that means is that you have to see pairs that are next to each other that are congruent, but not all four of them are going to be congruent. Okay, so we call this shape a kite. Okay, and now think about the equidistant theorem. So the diagonals in a kite are perpendicular, and that's because of the equidistant theorem. Okay, so the diagonals in a kite will form right angles, and you guys know this because if 2 points are equidistant from the end points of a segment, then when you connect those, that's the perpendicular bisector of that segment. Okay, so again, in a kite, the diagonals are perpendicular. One of the diagonals is the perpendicular bisector of the other. Obviously, right here is congruent to each other, again, because this is my endpoints of a segment. K is equidistant from I and E. T is equidistant from I and E. So if I connect T to K, it forms the perpendicular bisector of IE. Okay? One of the diagonals bisects the pair of opposite angles. Only one of the diagonals, which is the perpendicular bisector, actually, is going to bisect the opposite angles. So we can say that TK is bisecting ITE. Okay, so this angle is going to be congruent with this angle. And we also will know that this angle, IKT, is equal to this angle. Okay, and one pair of the opposite angles are going to be congruent to each other, and we can easily prove that by congruent triangles, guys. We can get this blue triangle by side, side, side equal to this blue triangle by side, side, side. But a shortcut is, because this is a kite, we know that this angle, angle I, TIK, is equal to this angle, TEK. Okay, so one of those pairs will get bisected by the perpendicular bisector, the angles, and the other pair of angles are going to always be congruent to each other. And again, you guys can prove this using triangles. Then we have the rhombus, okay? Rhombus, okay? So we have lots of stuff. Everything that is true about a parallelogram is also true for a rhombus. So opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals bisect each other, consecutive angles are supplementary. So all of that holds true, plus all of the properties of a kite. Anything we just went over with the kite, which means the diagonals are perpendicular bisectors of each other. This angle is equal to this angle, and this angle is getting bisected. So we have lots of stuff going on here with the rhombus. On top of it being the same qualities as a parallelogram and a kite, all of the sides are congruent to each other. So all these sides have to be the same. Okay, all of these sides have to be the same. Okay, the diagonals bisect the angles. Okay, so RO is bisecting angle MRH. I'll pick a different color. We got that. And RO is also bisecting MOH. Bam and bam. And because we know that opposite angles are congruent to each other, then we know that all four of those pieces are also going to be congruent to each other. Okay, the diagonals are perpendicular bisectors of each other. And even more importantly, so we have this perpendicular bisector. Because this is a parallelogram, I know this piece is equal to this piece, and I know this piece is equal to this piece. So if you guys take a look at this, you can very easily see 4 congruent right triangles, and that's important. So a rhombus gets cut into 4 congruent right triangles every single time. A rhombus will get cut into 4 congruent right triangles. Okay, then we have our square. Everything that happens in a rectangle is happening in a square. Okay, so go back to rectangle. So it's a parallelogram, and the diagonals are congruent, and there's right angles. So this is a parallelogram, the diagonals are congruent, and there are right angles. So everything that happened in a rectangle also happens in a square. Okay, that means opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. The diagonals are congruent. All 4 angles are right angles. So everything that happened in a rectangle is happening in the square, okay? All of the properties of a rhombus also happen in a square. So so all 4 sides are congruent, and these are split up into 5. Oh my goodness. These are split up into 4 congruent right triangles. So again, we have all of these angles are actually congruent to each other because they're getting bisected. So any orange dot that you pull out, you know it's going to be 45 degrees, okay? We know this piece is equal to this piece, which is equal to this piece and equal to this piece because the diagonals are congruent to each other, and like divisions are also congruent to each other. So we have 4 congruent right triangles here, okay? And they're 45 degrees angles. Those orange ones are 45-degree angles, okay? So this is split up into 4 congruent, what we call 45, 45, 90 triangles, okay? And we'll focus more on that in a future chapter, but for now we can refer to them as 45, 45, 90 triangles, okay? Plus it's a rectangle, plus it's a rhombus. And then the last one right here is the isosceles trapezoid. Okay, so the isosceles trapezoid, the legs are congruent. That's why it's isosceles. So there's 2 congruent legs. In this case, we have our TP is congruent to RA. The bases are parallel to each other. So the top and the bottom are going to be parallel to each other. On top of it, the lower base angles will be congruent to each other, and the upper base angles will be congruent to each other, okay? The diagonals will be congruent. So I want you guys to notice that in any upright shape, and by what I mean by upright is a rectangle is upright, a parallelogram is not. A square is upright, a rhombus is not. This is like an upright shape. It's not curved at all. It's not curved. It's not slanted, I guess you could say. It's upright. So we can also prove with, congruent side angle side really easily. But I can say because this is an isosceles trapezoid, that TA, the diagonal, is equal to RP, the diagonal. Okay, so the diagonals are congruent. And the lower base angles and the upper base angles, because of those parallel lines, end up being supplementary. So those have to add up to 180 degrees. Okay, so again, if this is 80 degrees, I know for sure this is 80 degrees, and then come over here, this has to be 100, and this also has to be 100. Okay, and that is my isosceles trapezoid. A way for you guys to remember this, and I like to really think about kind of what we call a family tree. We start off with the quadrilateral up here. So this is kind of my beginning shape, right? We have some sort of obscure quadrilateral. Branching down from the quadrilateral, we can have a parallelogram. Right? So obviously that's not beautiful. Parallelogram. So all of the things that hold true for a parallelogram also held true for, if you guys remember, if you go back to it, also held true for a rectangle. Okay, so here's how I like to look at it. This is like a family tree, right? This is you. You have all the characteristics of your parents, but your parents might not have all of the characteristics of you. Okay, so we have our rectangle that kind of fits in right there. We have a kite, so a quadrilateral can also be a kite. Trying to draw this nicely. So we can have a kite, okay? And we can have a rhombus. A rhombus is also all of the shapes of a parallelogram, if you remember. So a rhombus is a parallelogram. Right here. Okay, and then we have together, if the rhombus and the rectangle get together, they form our square. Square. Okay, and then we also have our isosceles trapezoid. Isosceles trapezoid. Okay, so again, if I told you something is a square, because a square is a rectangle, it is a rhombus, it is a parallelogram, it has all of the characteristics of all of those shapes. So a square has the characteristics of a rhombus and a rectangle and a parallelogram. So you have to memorize the characteristics for all of those different quadrilaterals.